Welcome. Let's solve Leetcode 2940. Find building where Alice and Bob can meet. Let's make this bigger so it's more readable. Um, you're given an array of heights with positive integers. Um, if a person is in building I, they can move to any building J if and only if I is less than J and heights of I is less than heights of J. You're also given another array queries where queries I equals AI BI. On the ith query, Alice is in building AI while Bob is in building BI. Return an array answer where answer I is the index of the leftmost building where Alice and Bob can meet on the ith query. If Alice and Bob cannot move to a common building on query I, set answer I to -1. Okay, it's a little bit complicated, but let's go over it. Let's go over this example here. So heights is 648,527, and let's look at this first query, 0, 1. So 0, 1 corresponds to this first building with height 6, and the other building at index 1 with height 4. 6 cannot move to 4, so the 0 cannot move to 4 because we're told that we can only move to a larger building. So in this case, that means since Alice cannot move to Bob, that means they both have to move to the right to find a bigger building. And that happens to be the 8 there, which is at index 2. So notice in the output how the answer has index 2 there. Moving on, 0 and 3. So 0, 6, and 3 is valued 5. So 6 cannot move to 5 because 5 is not big enough. So again, that means they both have to move. So the building that satisfies or that's big enough for both of them to move to is the last building, which is located at index 5. And notice that's the result here. Next, 2, 4. That's going to be 8 and 2. 8 cannot move to 2. So they both have to move. Notice though, if we move to the right, there is no building that's bigger than both of them. So notice how the result is a -1. Next query, 3 and 4 has 5 and 2. 5 cannot move to 2, so that means that they both have to move to the right. And there is a building that satisfies the height requirement. And notice how the index of the result is 5. Lastly, notice 2, 2. They're the same, and notice that the result is 2. So we're told that in the fifth query, Alice and Bob are already in the same building, so they don't need to move. Okay, I do want to go over this one slight variation here. So typically, I want to make sure this is not we're getting used to something that isn't always guaranteed. Notice how on the right, sorry, the left they have 3 and the right is 5. So do not be tricked into believing that the left value is always smaller than the right value. Notice here 5 and 2. So 5 would be 0, 1, 2, 3, 4, 5, which is 1, and 2 would be 8. So I want to make this clear. We could only ever move 8 to 1. We can never move 1 to 8. We're only moving to the right. So I want to make that point. The smaller index always moves to the bigger index. And now in this case, 8 could not move to 1 because 1 is too small. And notice how that means they both have to move, but there is no building that satisfies the height requirement. So notice for this query, with 5, 2, the answer is -1 because there is no answer. Okay, I just wanted to make that clear that we don't know who is at the higher building, Alice or Bob. So we'll just need to keep that in mind. I think this problem is a little bit challenging, but I've written some notes and that should help us make it easier. So there's 4 steps, and let's just attack this problem step by step. Okay, initialize the result. Okay, great. Well, we know that there may not be an answer. There may not be a building where Alice and Bob can meet at where the height requirement is satisfied. So that means there may be negative ones in our answer. Now the question is how many negative ones? Well, that depends on the number of queries. So we can just solve that now or set that up now. So let's set it up as result equals -1 times length of queries. Okay, great. And let's return a result. Okay, so that's one possibility. So that's just one step. Okay, great. Got that out of the way. Moving on to step 2. Try to solve the easy answers. Okay, so what are the easy answers? Well, remember from our example here, I think this was easy. When they're both in the same building, that's the answer. So we can just set that up now. So let's do it. So for K is the index of the query, and I'm gonna say this I and J in enumerate queries. If I equals J, then the result at K equals I. So this is the index of the query. So we set that answer at that index, and it could be I or J. We'll just set it I. Okay, that was easy enough. Next one, let's look at something like, I think this is a good example here. Maybe the 0 and 7. So 0 has the building 5 and 7 has the building 6. So notice though how 5 can move to 6. And so my point is whenever one person can move to another person, only one person needs to move. So that's our answer. The one with the bigger building should be the answer. Again, but that necessitates or requires that the smaller building is to the right. So we can only move a smaller to the bigger. If it's the other way around, then that wouldn't be easy. So let's go over that. So for example, in this case, remember if I is less than J, and what? What do we know about the heights? So we know that the height at I was less than the height of J. Well, what do we know? Well, the answer would just be the answer at J. I hope that makes sense. Now, the answer would be the same if we had the reverse. So something like, so it would just be the opposite of it. So else if J is less than I, if J is less than I, and what? This would be the backwards as well. So H of J is less than H of I. H of I. Well, what would the result be? So remember, we want the bigger building, so that'd be I. Okay, great. I think those are all the easy ones. Okay, so we were done with step 2. Let's take a breath. Okay, moving on to step 3. Now it says otherwise, so some of them, remember some buildings, Alice and Bob will both need to move to another building. So that's what we'll do here. We'll set that up. So otherwise, store the maximum index of a building. Okay, so let's look at something like this here when we were here. 0, 1. So 6 couldn't move to 4. That means we need to look for another building. So we can only look at a building afterwards. So we'll keep that in mind. So whenever we don't find an answer, like it's not an easy answer, we need to prepare to move on to the other buildings. So let's do that. How do we set that up? So I'm going to set it up in the store here. Store equals sorry. This will be fine. So I'm going to set a store here. So this will store where queries must begin search for solution. Okay. So this will store where queries must begin a search for a solution. Okay, so let's do that. So looking at this one here, so 0, 1, where do we need to look for a solution? Starting at what index? Well, we know that we know 1 didn't work. So that means we need to start at the next one. So what we do is we store it here. So we say, okay, else store at max of I and j. So starting afterwards, so like 0 and 1. So we start at the bigger index. Well, what do? We need to plug that in here. We need to store it and remember it. So what do we store and remember? What's important here? So we need to store, well, how about which query this is? Do we know which query this is? Sure, remember that up here? This is query K. That's query K. And what else? So what's important between these two buildings? How do we look for an answer? Well, remember, we need to find a building that's bigger than both of them. So should we store the 4 or the 6? Let's store the 6. Because that 6 tells us where to start looking for an answer. So how do we find the biggest building? We just say, okay, max of h of I and h of j. Okay, great. And I think that's it for us to quit or finish 1, 2, and 3. And what I am going to do is I'm going to print it out just so we get a better understanding of how we're progressing. Okay, so let's do it. So let's print the result, and then let's print the store. Let's print the store. Okay, is that everything? Okay, let's print it out. Again, I just want us to see how we're progressing so we get an idea. Oh, sorry. Okay, let's look at this here. Let's look at case 2 here. Case 2. Okay, so notice this answer and this answer are already done. So we did the easy answers, 7 and 6. Now we just need to check these other guys. So we couldn't find an answer here. Okay, so we found the easy answers. Those are coming along great. Now, what does this store represent? So this means this store is where we need to start looking for answers. So if you look at our first, the second example. So notice it wouldn't make sense that no queries ended at index 0, so we wouldn't look here. Looking up here, there's no queries that ended at building 1, so there's nothing here. There's no queries that ended at index 2. So the lowest one we have, I think, is here, 3 and 0. So 0, 1, 2, 3. And yes, so 3 and 0. So we have a value here. And well, what does this 5 and 3 represent? Well, this 5, if we look at 3 and 0, so here's our heights. So 0 has a height of 5, and 0, 1, 2, 3. So remember, we stored the maximum height that we're looking for. And this 3 represents the query. So 0, 1, 2, 3. So that's what it means. That's what this store represents. It stores where we start looking for answers and the height of that building that we can look for. So this height, though, we can look for only after here. And this is just the answer. So I just want to make that clear, what this store is holding for us. Okay. Okay, great. So now let's move on to the next one. Let's loop through our building heights, checking if any queries ended before the current building index and current height is greater. If so, pop from queue and start result. Okay, so let's go over what that means. So first, we want to start looking at our heights. So for in heights, so what do we call this? We'll say I, comma h in enumerate heights. Okay, so remember though, what's a good thing to do? So heights. How does this index and this store, how do they, how do they, uh, how do they relate to each other? So remember though, when we're here at I, that means afterwards we can start looking for an answer. So if we're, for example, at index 3, we can start looking for answers at index 4. So I want to do something here. So we need to store where we can look for answers. So let's do this here. So Q, I'll set this equal to Q. So this is where we'll store, let's see, like hold queries in need of an answer. Okay, so let's do this here. So right here, I'm not going to do it yet, but I'm going to do some work finding answer with current building height, which is this H here. Okay. Otherwise, though, I'm going to do this here. At the very end, though, I'm going to add. So I'm going to say, okay, for S in store I, heap push Q S. Okay, so let's go over what happened here. So don't worry about this here. Remember though, once we've gone here, once we can only look for answers after on the next level, on the next iteration. So for example, let's go back to this here. I want to make this perfectly clear because this is the hard part. So remember here, 0 and 1. So the max of 0 and 1 is 1. So if the height is 1 here, so the 1 is 1, 4. We can only start looking for an answer at when it's 2. So notice at the end I add this value to the queue. And now so when I come back around, now it's at 2, and then I can start looking for answers. So I want to make that clear. That's why I added at the end. Okay, so I hope that this is a little bit tricky. So remember, when our height is at 2, that means anything before, if there was a query that ended, we can look for an answer there afterwards. So I just want to make that clear. Okay, I think that's okay. And now let's do the work. Okay, cool. Okay, so this is a min heap. So what we'll do is we'll say, okay, while what? While we have an element on the queue, and so we want to check if the current height, so if this height is bigger than what? So the first element on the queue, which is the minimum. And well, remember our queue is storing what? This queue stores S. And what is S? S was this here. So remember, this will store, this was storing the maximum height. So the height and the query index. So think about it like this. So this would have 6 here. And then, okay, then we move on to the next guy, which is 8. If this is greater than which one? So this is the top one. So this first value is the one I want, the height. Okay, great. This is looking good. So we know we have an answer if this is true. We found a building bigger than these two guys. So that means we do what? We can say, okay, result. So we need to get that. We want to say, okay, heap pop Q. And this will equal what? This will equal, well, it'll equal the, I don't know, it'll equal the, this is called the height and the query index. I'll just put it like this for now. Okay. And then so we say, okay, well, we're more concerned with the query index. Now remember, the answer that goes here is the location of this building. Where is this building at? It's at building 2, which is here. So we can say this is I. So I hope that makes sense. Okay, cool. And I think that's it. So that means no longer are we looking for an answer for 0, 1. So that's why we popped it. And I think that's it. We're done. I know that was tough. Anyways, let's check it. Make sure I'm sane. Okay, looks good. Let's submit it. Okay, looks amazing. All right. If you have any questions, or if you felt this was, well, if you have any questions, please comment and ask me the question. I'll try to clarify. Otherwise, if you felt this video was helpful or educational or beneficial in any way whatsoever, please consider liking or subscribing. Other than that, have a wonderful day. Take care of yourself.